Let's do lecture 3. Here it says, perform the following tasks to the best of your ability, and only afterwards should you check answer at the end of the lecture. Although the answer do not come with any explanation, you should try to figure out what you did wrong and why. If some concepts remain unclear, the reader should not panic for. This is quite expected. Very similar concept will be reintroduced and reintroduced, and as time passes by, everything will start to make more sense. Examine the chart and answer the question. Here we can see that this is a straight line whose equation is 1.5x plus 50, and the x-axis is the number of math credits in a university and annual salary in $1,000. So we can see that as number of math credits at the university goes up, the annual salary of that instructor also goes up. What is the slope of the line? You can see that this line is in terms of y equals to mx plus c. So m is 1.5. That's why we can just go for 1.5. Okay, let's check. What is the y-intercept? Y-intercept is the point in y-axis where the line meets. So this is the y-intercept. It should be about 50. As a person takes more math classes, does the equation suggest that his salary will increase or decrease? Is this expected? Yes, it is expected, since you can see that this line, it increases as number of math credits increases. It increases, and yes, it is expected. Okay, yes. If a person A has taken X math credits in his college and person B has taken 10 more credits than him, what can you conclude regarding their respective salaries? So B will earn more. Person B will earn more than person A. Examine the chart and answer the following question. Where here you can see that x-axis represents weight in pounds and y-axis represents height in inches. And this dot plots are scatter plot are gathered around this point 140. So let's answer the questions. What is the approximate average weight for the subjects presented on this chart? Average weight should be somewhere around 100 pounds, right? So let us go for that. 100 pounds. Yes, good. What is the approximate lowest height for the subjects presented here? Lowest height. Let's click. Yeah, about 22 inches. That's fine. Does the data present a positive or negative trend, or no trend at all? It shows a positive trend, since you can see that as we look through this scatter plot, then a bunch of scatter plot rises up. You can see this could be the trend how it goes. So yeah, this is a positive trend. What is the approximate range for x-axis data in x-axis? So this would be somewhere around 50 up to, let's say this is 150, 145, 50 to 145, 50 to 145. Okay, pounds, good. Yeah, I forgot to write the unit. What is the approximate average for y-axis? That should be somewhere around 40 inches. Okay, that's fine. Here you can see that this is the data or the example that we have already seen in lecture 1, I suppose. Before we proceed with the next task, let us revisit an earlier one. Given the data 1 is this and data 1, 2 are given. The average of data 1 is computed as add all of them and divide by the total number of these data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So divide by 11. So that's 3. And the median of data 1 was computed by first arranging them in ascending order. Okay. And then you count, you exactly choose the term in the middle. Okay. So that's it, which is 3 in this case. Range means you need to subtract the smaller one from the largest one. So maximum minus minimum. That would be 6 would be the maximum and 0 is the minimum. So 6 minus 0 is 6. Now variation, you can clearly see that data 1 ranges from 0 to 6, whereas data 2 ranges from 2 to 4. So you can clearly see data 1 has more variation than data 2. Task 3, examine the chart and answer the questions. So data A and data B is given. Both represents days in the x-axis and temperature in the y-axis. So here you can see that all the scatter plot in data A is crammed somewhere from, let's say, 70 to 100, less than 100. And here in data B, all the data ranges from nearly 38 to 95, let's say, something just like that. Okay. So here let us answer the question, which of the data files has higher average, data A, data B? Of course data A has higher average, since the higher average would be somewhere around 85, but in data B the average would be somewhere around 70 or 75. So A has the higher average, data A. Which of the two data files has higher variation, data A, data B, or they are approximately equal? Higher variation means how much the data has been spread. So you can see that data B has spreaded far across from, let's say, 38 to 95, whereas data A is not widespread, just like data B. So B is. Which of the two data files has higher median, data A, data B, or they are approximately equal? Here you can see that the data B ranges from 38 to 95 and data A ranges from somewhere around 75 to 100. So this is quite less, and we have already approximated the average to be somewhere around 85. And medians, they always lie somewhere near around the average, so we go for data A in this case. Which of the two data files has the wider range, data A, data B, or are they approximately equal? Wider range, the range of the data is wide in B, data B, so that's data B. Okay, that's good. Task 4. Examine the chart and answer the question. Data A and data B are given. X-axis constitutes of number of students and their salary in $1,000. In both of these cases. So here you can see that in data B it's quite consistent and everything is crammed in between, let's say, 70 to 95, whereas in data A it starts from 75 and goes up to goes beyond 160 or 70. That's approximate. So which of the two data files has higher average, data A, data B? Are they approximately equal? Of course data A should have higher average, since there are outliers. Few of the data points are way above, so that will pull the average a bit more. So that's A. Which of the two data files has the higher variation, data A and data B? So you can see in data A it has spread much more than data B. That's data A. Which of the two data files has the higher median, data A, data B, or are they approximately? You can see that the median between these two would be approximately equal. Okay, so which of the two data files has wider range, data A or data B? So of course the data A has wider range since it is scattered more. Okay, now let's go on to task number 5. Examine the charts and answer the questions. Here data A and data B are provided where the x-axis is about days and x-axis represents days and y-axis represents temperature. So now you can see here that this data A ranges from, let's say, 70 up to 105, and here also we have the similar kind of thing. It ranges from 65 up to 110. So they are slightly equal in terms, approximately equal in terms of range. If you go for average, then it should be nearly 95. Here also we can see that it should be nearly 95, and median also will be nearly about that, since this is quite consistent kind of data. Okay, we don't have quite much variation, and so median are also nearly same. They don't have a lot of variation in both of these. Slightly this is varied, data B is varied, but not so much. It doesn't matter too much. Okay, so here, which of the two data files has higher average, data A, data B? I feel like they should be approximately equal. So let me just copy this and push it here. And okay, so I'm good. Now again, which of the data files has higher variation in data? Okay, this is varied a bit much, but it's not way varied than data A, so they are approximately equal in this case also. Which of the two data files has the higher median, data A and data B? As we discussed earlier, they should also be approximately equal. And which of the two data files has wider range, data A, data B? Well, they are somehow nearly the same. Okay, they don't have drastic difference between them, so they are approximately equal. So that's all about these 5 tasks. Now mean, median, and standard deviation. Mean, median, and standard deviation, they are the basics of statistical analysis that we will be studying, and also not only for our course, anywhere you see, no matter whatever statistical analysis is done, it is based upon mean, median, and standard deviation. Primarily or basically mean and standard deviation. So mean is the average and standard deviation is the dispersion or variation of the data with respect to mean. So how far, so think about a circle and think mean is the center of the circle and standard deviation to be the radius of that circle. That's how we should understand about mean and standard deviation. Mean is the center of the data and standard deviation is the radius. Okay, as I was telling you all that mean should be considered as the center of the distribution, so that's mean. And standard deviation should be considered just like as if it were the radius of the circle. So this circle will consist of 65% of the total data, and so this is the standard deviation, which is the radius of this circle, and let's take twice standard deviation. So that means let's elongate this radius, then it will be something just like this. Then this big circle will constitute of all the 95% of the total data, and here this is also one. This is twice standard deviation, so 95% of the data lies in the outer circle, the bigger one, and 5% might contain outliers. So for that, which we must be very careful. And in the lecture 3, you can see that there is a nice example of an outlier. Let's go for that, which says that Annual income. Clearly, an average annual income for a town or city would be greatly swayed, will be highly changed if a billionaire moved in the neighborhood, right? So that's how it works. That's outlier. Okay, that's it.